right, this video is the final lesson for dual credit stat students. We're talking about inverse calculations. Now, if you're a face-to-face learner in my class, we've briefly discussed these, but I want to go into a little more detail and work an example and talk about the processes. So you will need your Inspire, so go ahead and grab that for this, just to get a little extra practice with it. I think distance learners, you have not done this yet, so make sure that you have your Inspire ready. I'm going to go ahead and go to my desktop here. Get your Inspire ready. We're going to be using a function on that. I'm going to post a link to these practice problems for you guys so you can maybe try these. But we're going to go ahead and look at this example here. This is a little bit different than the normal calculations that we've been doing, where we press menu, probability, distributions, and normal CDF. So this is 552. We're going to be doing inverse normal distributions today. Okay, so as you can see the topic up here, it says normal calculations in reverse. Here's what we get. This is what the questions look like. The distribution of average wait time in a drive-through restaurant lines in one town was approximately normal with a mean of 185 and a standard deviation of 11. Amelia only likes to use a drive-through for restaurants where the average wait time is in the bottom 10% of that town. So she likes the speed, okay? I'm going to go ahead and draw what this looks like. So let me move this over. Okay. And we're going to draw this distribution. So we know that it's normally distributed. So we're going to draw, let me draw a blank one here. You can do this in your notes as well. We want we have a mean of 185. And we're going to have 3 standard deviations above, 3 that are below. We're going up by 11 each time. So it's 196. 207 and then 218. Going the other direction, we're taking away 11, so we're at 174, 163, and 152. All right, cool. So let's answer the question. It says we want to know, we want to figure out the bottom 10%. What is the wait time? What is that average wait time? So here's the average wait times in seconds. And with deviation, so the average is 185, but what would the bottom 10% be? Well, let's think through this logically first. We know that from here over, this would be the bottom 50%. And then we've practiced a little bit, and we have our areas. We know that less than 1 deviation, okay, so 2 and 3 deviations are beyond, negative 2 and 3 deviations beyond, is going to be 16%. That way. And then from this deviation over is 2.5%. So we know that this is going to have to fall somewhere in here. If we're thinking about it logically, it has to fall within that interval. Now that might actually help us out in some way. Actually, we can pretty much answer this. Well, no, it could be A or B is sort of where we're at, okay? But what we're going to be using is a inverse normal calculation, okay? So we need to find the bottom 10%. And so we're going to be doing an inverse normal calculation. And what that is on your calculator, that is menu 553. So let's go ahead and look at that. I'm going to pull that up and let's type in what we need for this. So let me over here. So we want menu. Make this. Let me adjust my screen here. It's been kind of weird. I'm doing a lesson from my school laptop because I did not do it at home. So menu 553. Inverse normal. So now what it wants is the area. Now this is the percent. Okay, so let's talk about area. Area is always in decimal format. Okay, so that means we're saying 10% is what we want. So let's go back to the calculator. We're going to put in 0.1, okay? Then we're going to put in the mean. We know that's 185. And then the standard deviation is 11. We're going to hit enter. And there it gives us our value, okay? That's going to be our best estimate for what that would be. So 170 is going to be the closest one, okay? So we know that this is 170, okay, approximately. So let's go ahead and click that. Got it right. Let's try another example. So let's. I guess we're going to need to do this one. I'm going to draw a simpler diagram. Hold on, I need to zoom in. Okay, we're going to draw this one. I'm not going to spend as much time creating it. So this is 66,000. And we know the standard deviation is 22,000. Okay, so up 22,000, and I need to write this as, let me write this a little bit different, just so that it's a little bit nicer. Let's do 66K. We know that this would be 88K. We go up another and another, so we get 110K. And then we're going to get 22,000 more. We want 132K. Okay, so we're trying to find the top 5%. Okay, well, we know that from here over is 2.5%. And then from here over is 16%. So it's going to be somewhere in here. So we know we want that percent. Now, here's the problem. Let's go back here. We'll do that, the same thing, menu 553, inverse norm. And if you put 0.05 as the area, we're going to run into an issue. We're not going to get the right answer. 66,000, and then we want 22,000 right here. Okay, so we get 29,813. Now, why is this a problem? Where is 29,000? Is it up here? It's not. It would actually be going this way. This would be 44. This would be 22. And then this would be 0. Right? We're going down by 22,000. So it would be over here. Now that can't be correct. So here's the problem. Okay? Here's the issue. And let me go back over to where we wrote. We're going to write this note here. Another star. Put this in your notes. The area is always expressed as a percentile in the calculator. Erase. Why won't that erase? I don't know why that's not erasing. Okay, scratch this. Hold on. In the calculator. Okay, so let's talk about that. If I go back and I want to do this calculation over here, we want to find the top 5%. So what is the percentile for 5%? If you're in the top 5%, what does your percentile equal? Would it be the 95th percentile, right? This was not a problem for us over here in this one because we had the bottom 10%. That is the 10th percentile. So over here, that's the trick. If it says top percent, you need to submit. So we'll do menu 553. The area should be 0.95. That means 95% of the data is less than that. The mean is that 66,000, and the standard deviation is going to be the 22,000. This is going to give us the right answer. So I'm going to hit OK. And we get 102,000. Let's compare that to our graph. We knew that it needed to be between 88K and 110K. So this seems reasonable. Let's go to our answers here. 102,000, you can see we pretty much have it dead on. Okay, So I should have linked, I'm going to put this link in the video of where you can come here and practice this. There's actually quite a bit of good topics on the left side. So if you want to brush up on some of these normal distribution problems, you can absolutely do that. Finding z-scores, all this stuff. Some of it might be geared towards AP, but you can definitely feel free to check that out. I'm going to go ahead and stop things here.